Okay, so for another method of evaluating the limits class is this L'Hopital's rule. Okay, so according to this rule, you can evaluate the limits by simply getting the first derivative of a given function. Okay, so but since we are not yet, or I haven't introduced yet to you the derivatives or how to derive, then we cannot use this. But of course, I'll just introduce this to you so that later, once na malaman na natin paano mag-derive, so it will be easy for us to determine the limit na. So simply, kung given ka ng function, let's say f of x, so just get the first derivative and divide it with the derivative of the another function. And then, substitute mo lang yung kung saan nag-approach yung x niya. Again, this L'Hopital's rule includes derivatives. So again, we cannot have examples, but I'm introducing it to you. Now, regarding class with limits, we have another situation where we may be encountered with a trigonometric function. Trigonometric function involves trigonometric identities like sine, cosine, tangent, cosecant, cosine, something like that. And if you could recall in your trigonometric subject or trigonometry, we have these identities. Okay, if you could recall, we have here the reciprocal identities. So tangent can be taken as sine over cosine. Your cotangent is cosine over sine. Your cosecant is the reciprocal of 1 over sine. And second is 1 over cosine. As well as we also have the Pythagorean identities, where sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta is equal to secant squared theta, and blah blah blah. Also, we have the addition and subtraction of the trigonometric functions as well as the double angle formulas. Now, why are we talking about this functions class? Why are we recalling, or why are we reviewing this identities as well as the formulas? It's because class, we can use this, or this can help us simplify the given function if we are encountered with this type of functions. Okay, so we can manipulate by determining, or by knowing its equivalent function here. So how are we going to get the limit of a trigonometric function? So the same class as we have done with other functions. So to get the limit of a trigonometric function, so we will simply substitute your x. So whatever the value of your x there, so just substitute it with the function. But take note class, take note that when evaluating, especially if you are using your calculator, your mode should be in radian mode. Again, when evaluating a trigonometric function, you have to set your calculator in radian mode. Okay? You have to set that. Kasi para mabigay niya yung sakto na sagot sa iyo. Okay? So, simple as that class. Isa-substitute mo lang kung ano yung value ng x. But then, there will be cases also class na magiging indeterminate yung ating mga function or yung result, katulad ng nangyari sa atin sa last time, di ba? It could be na yung result, pag substitute mo, is 0 over 0 o kaya infinity over infinity, yung mga ganong cases. So, ano yung gagawin natin? Katulad nito class. Ito. In this type of function, if you can see, di ba? Limit of sine x over x as x approaches 0. So, kung isa-substitute natin class, dito yung 0, magiging sine 0. O, ilan ba yung value ng sine 0 natin? Sine 0 is 0, di ba? Over x pa. So, 0 over 0. Oh, paano naging equal to 1 siya? Okay, so this is already proven, because if you want to know the explanation behind this, you can search the internet class. But when you are encountered with this kind of situation, etong sine x over x, okay, remember na always siyang equal to 1. Nakukuha nyo? Again, this is already a theorem na pag naka-encounter ka ng sine x over x, automatic, the limit, if approaches to 0 is 1. Okay? Automatic na yan, class, ha? Pag ganito yung theorem na kasi natin yan. Halimbawa, ganito yung equation natin. Evaluate the limit of 1 minus cosine theta over theta. Okay. Sige. So, try natin na 1 minus cosine theta over theta. Sige, isulat muna natin, class. Sulat muna natin. We have here one minus cosine theta all over theta. And then, ano nga yun? Theta approaches 0. Okay. What is the limit as theta approaches 0? Okay, class. So, sabi natin, when it comes to trigonometric function, di ba, sabi natin, just substitute whatever the x, or in this case, class, hindi siya x, ha, is theta. Okay. So, if you substitute 0 instead of theta, what will be the results? So, 1 minus cosine 0 all over 0, right? But then, cosine 0 is how much, class? If you use your calculator, take note, class, your calculator should be in radian mode. Yan. So, evaluate cosine 0, equivalent is 1, right? So, 1 minus 1 is equivalent to 0. So, you can see this is indeterminate. So, ano yung gagawin? So, based sa natutunan natin no previous na mga methods, so pag naging indeterminate yung result na it could be 0 over 0 or infinity over infinity, yung maging result, then you have the choice. You could do factoring or pwedeng kunin mo or applyin mo ng conjugate. Diba? Na in this case, let us apply conjugate kasi hindi natin factor to, class. We cannot factor out the theta here. So, let us apply conjugate, ha? So, ano ba yung conjugate ni 1 minus cosine theta? So, the conjugate is, 1 plus cosine theta. Yung papalitan mo lang yung operation niya. So, instead of negative, positive. Yan yung conjugate. So, 1 plus cosine theta over 1 plus cosine theta, which is equivalent to 1 naman, di ba? So, i-multiply natin. Pag multiply natin ito, so, this quantity here, multiplied here, so what will happen? Okay, isa-isahin natin na 1 plus cosine theta. Yan. Well, eto naman, theta, 1 plus cosine theta. Okay, eto. So, this will be, if you multiply, this will become 1. How about this one? Plus cosine theta. And then, how about this one? Minus cosine theta. And how this one? Negative cosine squared theta. Okay, so what will happen here? Your cosine theta will be cancelled out. Follow? 1 plus cosine theta. There. So, your equation will become 1 minus cosine squared theta all over theta 1 plus cosine theta. Do you follow? Do you follow, class? Now, how are we going to simplify this? Now, if you could recall, class, doon sa trigonometric identity natin, dito, if you could recall here, this one, here, what can you see? Right here, we have here, we have here um, equivalent, eto kasi di ba kayo na 1 minus cosine squared theta yon. Tama? Ito 1 minus cosine squared theta. So, hanapan natin siya ng equivalent. Ito kung makikita nyo ito class 1 ito. So, kung i-transpose mo itong cosine squared theta, so 1 minus cosine squared theta is equal to sine squared theta. Okay, so yan yung gagamitin natin class. So, instead of this one, okay, so magiging sine squared theta na lang siya all over your theta, 1 plus cosine theta. Do you follow? 1 plus to 1 plus. Okay, balikan natin. So, this will become 1 plus here. Now, if we simplify further the equation class, so sine squared theta is equivalent to sine theta times sine theta all over theta 1 plus cosine theta. Tama? Kasi sine theta times sine theta is sine squared theta, right? So we can simplify it like that. But then we have a theorem, right? That if you evaluate the limit and you are approaching 0, and if you found ganitong format kanina, eto, pag ganito yung format niya, automatic 1 siya agad. 'Di ba? Automatic siya na 1. Eh ngayon, kung nakikita nyo dito, meron ba tayong ganyan? Sin x over x? Yes, meron tayo class. Pero in the form of theta naman siya. Ito, sin theta over theta. This is tantamount to sin x over x. So, this is equal to 1. Right? So, therefore, masisimplify siya as 1. Nakuha nyo? So, 1 siya, and then, since 1 ito, so mamumultiply siya as, the equation will then become sin theta over 1 plus cosine theta. Do you follow class? So, itong buong quantity na to magiging theta, 1 na lang siya. Ngayon, dito na natin i-evaluate yung ating function. So, substitute lang natin yung 0. So, 1 sine 0, 0, I'm sorry. Sine 0 over 1 plus cosine 0. 0, I'm sorry, ba't nagiging theta palagi? This is 0. Okay, and if you compute that, sine 0 is how much class? Sine 0 is 0. Okay? 0. How about cosine 0? Cosine 0 is 1. Plus 1, that would be 2. So, ilan nga yung 0 over 2? Plus 0 over 2 is equivalent to 0. Do you follow? So, therefore, the limit of 1 minus cosine theta over theta as theta approaches 0 is equal to 0. Okay, so that is our answer in that situation. Okay?